Hello and welcome back. Let's demystify some of misconceptions about class relationships and the class data members. This video is going to help you with your interview and some tricky questions about object-oriented programming in Java, especially about class data members and hierarchical relationship between the classes. So what I'm gonna do is I'm going to create some classes here inside this package. Right click, Java class. So I'm gonna show you the relationship between classes using inheritance. So what I'm gonna do is I'm gonna create a child class. You call it whatever class name you wanna give it, but I'm gonna give it a child class here. And if I go to the main method, I'm gonna put the child class here. I can create objects of the child class, right? I have a class here, a blueprint for the object, and I can create as many objects as I want for this class. I can call its constructor using the new keyword. I can say child c1 equal to new child. What happens basically here, we are calling a constructor of the child class, but we don't have any constructor here. A method that has the name same as the child, but we don't have anything here. If we don't provide any constructor in a class, the compiler is going to give us a default constructor. Right now, we are able to create an object of the child class. If I run the code, we don't have any problem. The object is created because the compiler is going to give us a default constructor. So we're going to take everything step by step from the basics, and we will get it to more advanced concepts. Okay. First, we have to understand the flow of execution. If we don't provide any constructor, by default, we know the constructor is a special type of object that has no return type and it has the same name as the class name. So the compiler is going to give us something like this. This is called a no argument constructor or no arg constructor or the default constructor, right? So if I have a statement here, for example, child no arg constructor. So as soon as we make a call to the constructor of the child class, if I close this one, so the flow of execution, what happens is we are calling the constructor with no argument constructor. So and a call will be made to this function, right? And we execute this line of code. And if we have object instant initialization, we initialize the object, we instantiate the object. An object will be created in the heap memory. Once we create an object in the heap memory, an address of the object will be returned. So the new keyword will return the address of the object from the heap memory, and the address of the object will get stored in this reference variable of type child. We know that, right? So this is the flow of execution. If I run this, we can see a print statement here inside the child constructor. We can also visualize that using the debugger provided in IntelliJ IDEA. It's a wonderful tool. I recommend you to use it. If I put a breakpoint here, just click here, you will get a breakpoint or a circle here, and we can debug our project to see what basically happens, what values get assigned, what values we are passing around in our program, and what is the flow of execution. So as soon as I start debugging, I can, my execution is here, the control is here right now. In this line of code, I can use to jump into or step into a function call or step over a function call. So we want to step into this function call or constructor call. See, as soon as I click or step in, our execution come here. The controls come to the child constructor and we make a call to the child constructor. Let me step in again. This line of code gets executed and we return. An object is created, instantiated, and we return back here. And if I go back right now, C1 stores a reference to a child class. This is child at, and we have hash code representation of the child. This is not the memory address. This is a hash representation of the child object inside the heap memory. We know that what basically happens here is we have a stack memory. Let's say if it's a stack memory, what I did. Then if we have a stack memory here, stack memory area, and we also have a heap memory area, we know all this, like how the objects are created. Heap, the instance variable c1 is created here. C1 does not store the object itself, a child object. So the new keyword is going to create an object inside a heap memory. We will have an object with all its members if we have variables inside the class. And this class will create an object inside the heap memory. And it will have an address, for example, let's say 6,800, for example. And this address will get returned, and we store this address 6,800 inside this C1 reference variable inside the stack memory. And when we make a call C1 dot and we want to get access to the members of this child class, we dereference this memory address and we point to this object. Okay, in the previous video we learned about these concepts. So let's not go to that route. What I'm going to do is, now let's create another class. If we have another class here, let me put this one here maybe. If we have another class, maybe create a hierarchical relationship between the classes. Let's see what happens. If I go back here to open this project window, I can press Alt 1 or click here. So I'm going to press Alt 1 to open that one again. Right click, and I'm going to create another class. Let's call it parent. You can call it anything you want. I want to have a relationship between these two classes. I'm going to put it here. A hierarchical relationship between the two classes. Alt 1 to hide this one. Okay. I want to have a child class extends the parent class. So what happens here, we are inheriting some properties of the parent class from the child class. In other words, we are building a child class based on the parent class. These are the inheritance relationship between the classes, or we call it the ASO relationship. We know about this. Hopefully you know. So we created a relationship, the ASO relationship. So what happens now when we create an object of the child class? So this line of code gets executed, this constructor gets executed, we build the child class. But as I said, inheritance is an ASO relationship, and we built a child class based on the parent class. This is the concept of inheritance. Inheritance is all about code reusability. We want to inherit some properties, some fields, some methods, some behaviors from the parent class, and instead of rewriting them inside the child class. In order to inherit something from the parent class, we first must build that object, the parent object, to inherit something from that. Okay, we must build that object, and then we can create a child class. So now what happens, the execution, when we call the child class constructor, before we do anything, it will make a call to the constructor of the parent class to instantiate, to build, or to create an object of the parent class first. Then based on that, we can create an object of the child class. So if I have, for example, right now we don't have any problem because the compiler is going to make a call to the constructor of this class, but we don't have any constructor here. We said the compiler is going to give us a default or no argument constructor if we don't provide anything. So what happens is the compiler is going to make a call like this. Super, using the super keyword, we can call the constructor of the parent class. First build this one, call the no argument constructor of this, then we build this one. So if we don't put it, the compiler is going to put a super here. Okay. So now what happens if I have something like this? If I have a name for the parent, for example, string name, what I'm gonna do, I will define another overload of the constructor. We know a constructor is a special type of method or function inside the class that has no argument, and it has the same name as the class name. Okay, so public, no return type, and we give a name to our constructor which is the same name as the class. So the compiler is gonna give us this one by default if we don't have anything, right? So if I print something here, is out, parent, no or constructor. Now what would be the flow of execution? We make a call here, but before we do anything, we make a call to the parent constructor, and we print this one, and then we print this one. Let's see the flow of execution, but we are not manually making a call to the parent constructor inside the child constructor. As I said, if we don't do that, the compiler is going to make a call by default. It is going to give us super, to call the super parent, super constructor, or the parent constructor. See? So our execution is here. We want to make a call to the child constructor. We come here. But before we do anything with the child constructor, we want to make or build the parent constructor. We make a call here. We don't do it manually, but the compiler does it if we don't provide anything. See, the execution came here. This line of code get printed. And we came back and we build the child or instantiate the child class. So before anything, we must build or instantiate the parent class. A parent class is built. You cannot see anything here because I already exited. If I go here, see, the child object is already created. So, but what happens if I do something like this? Now let's see. If I say another overload of the constructor, I can do as many overload of the constructor as I can. Public parent. In this constructor, I want to accept a string name, and I just want to set this dot name equal to name. What we are doing here, we are accepting a local variable from the constructor. This is a local variable to the method or to the constructor. We accept it from outside, so this value comes from outside when we make a call to this this constructor of the parent. This is a local variable, and we set this local variable here, and we set it to our instance variable, okay, or to member variable. Why we use this keyword? We use this keyword to differentiate between the local variable of the method and the instance variable or the class name variable. Okay, so this dot name refers to the this variable, and this only name is a local variable to the function. That's why we can see different colors here. A purple color means that it is a member variable, and a white color means it is a local variable of the function. Okay, but if I don't have a this keyword here, let me see. If I don't have a this keyword, so I'm going to click here. What happens here? We're not doing anything. We're taking the local variable and set it back to the local variable. We're not setting any value here. But if we put a this, so this refers to the current object, to the current instance of the object. Okay, what object this constructor is called upon, this keyword refers to that object, and we create a copy of this instance variable and make a copy and set the value for that specific object. Okay, as I said, instance variables are unique per object, and we have a separate copy of each instance variable per object. Okay, so that's why this instance variable or non-static member variables make each object unique. They can take different values for each object. Okay, they belong to the object of the class, not to the class itself. But if we come to the instance variable, then we that instance variable is going to belong to the class itself, not to the object. So before that, I'm going to print something here. Parent uh, or constructor. So I'm gonna remove this. But what happens if I don't provide the default constructor here? Say I don't want to have a default constructor. I just want to have one constructor that accepts a string and set the name. As soon as I remove the default constructor, we get an error in the child constructor. Our compiler complains our code doesn't run. Why? Because by default, when we create an object of the child class, the compiler is gonna make a call to the super keyword, a super constructor with no argument. But we don't have any super uh, uh, a constructor of the parent with no argument. Remember, I said if we don't provide that, the compiler is gonna give it to us. But why the compiler is not gonna give it to us now? Why the compiler is not gonna give us the default or no argument constructor of this class or parent class? Remember, as soon as we overload the constructor, or as soon as we provide a definition or an implementation of the constructor, in that moment the compiler is not going to give us any default constructor, and we have to implement it by ourselves. We have to implement a default constructor here or a no argument constructor, because the compiler from the child class is going to call this to build the object of the parent class. Okay. So what we can do here, if I go here, it says um, expected one argument, but we provided 0. Okay, because we by default the compiler is calling the no argument constructor. If I go here, remove that, there is no default constructor available in the parent class. We can insert this from here, or we can just define it by ourselves if we have any instantiation or initialization. As soon as I provide a default or no argument constructor, the error is gone. So now, when we create an object of the child class, this gets executed, but before that, this line of code gets executed. Then we'll print this one. So first, the parent no argument constructor and the child no argument constructor. This one doesn't get executed because we are not calling that. But what happens if I have another child class? Let's see, child with name. Let me call it C2, and I want to pass it child class. Can I do that? No, because I don't have any constructor inside the child class that accepts a string. I can create another maybe overload of the constructor inside the child class, public child. This time this takes a string and we call it name. The error is gone, right? So, but what should we do with the name? We don't have any member variable in the child class to set the name. The name belongs to the parent class, right? And we're gonna set it here and inherit it back from the parent class. So we can use a super class, a super keyword, to pass data or make a communication between the parent class and the child class, right? Super, this is going to call the default constructor, but we have a name. We want to pass the name here to this constructor. We have another overload of the parent constructor with a string, so we can pass name here. So now this constructor doesn't get called, this constructor will get called. And I want to print something here, is out child arg constructor. Now what happens if I comment out this line of code? If I put it here and this one here, so the execution comes here when we say child, new child with an argument constructor. We're calling a constructor that accepts a string. The execution comes inside the child class. So the child class have a overload of the constructor that accepts a string. But before we do anything, we want to make a call to the super constructor, and we want to pass this variable because we don't have to do anything with this variable. We don't have a member variable. So this name variable doesn't belong to the child class. It belongs to the parent, and we can um, push it up to the parent class using the super. We can pass data between the classes. So it's going to make a call to this constructor. Name comes here. We just want to print this line of code, and we take the name variable and we set it to this instance variable of the parent class. Once we come back here and the execution come here, we print this line of code, child argument constructor, and the flow of execution come back here. The new keyword, it will return an address of the object from the heap, and the address gets stored in this reference variable, or a reference to the object will get stored to the C2. If we run it, if we go here, maybe put a breakpoint. So this time, if I debug, we're calling this version of the overload of the constructor. If I do that, see, here I can see the name and the value of the name, what value the name comes, or the value that is provided. I can see it visually. We know the name has this value child, and we pass it to the constructor of the parent class. So the call will come here. If I step in again, the call come here, and we can see the value of the name still has a child. If I go here, right now this instance variable is null, nothing is set here. By default, the default value of a string is null and integer is 0. We know that. If I go further, this line of code gets executed. Further, we set the name. The local variable, or this name, has a child value, but the instance variable is null. As soon as we see this dot name, we are setting the value here. Okay, let's step further. So name has a child value, and the name, which is the instance variable or the class variable, also has a child value. If I come here, see, we set the child value to the name. And once we are done, we come back here to the child constructor, and we are constructing and instantiating the child class. We come here, and whatever instantiation or logic we have, that will get executed. Here, this line of code will get executed, and we exit out of this constructor, and the object is created. Right now, C doesn't have anything. The object is created, a reference to that object will get returned, and we will store it to the C2 variable. If I go step, now C2 has an object, and this is the hash code representation of the object, and this is the class name at the hash code representation of the object. Name of the object is child, the type of the object is child, and inside the C2 we don't have the object directly. See, we have like address, memory address of that. This is not the memory address, but this is the hash code representation of the object. If we can see that what values are stored in this child object, we can visually see that using the debugging tool. If we click that, so this is I believe this is the argument. Let's see. Let me step in a little bit, and we get out of the main method, and we see the welcome is printed first. First, the parent constructor gets executed, and the child constructor gets executed. So now let's see if I have if I go to the parent class, beside the static members, we can have instance members also. The members or the data member that belong to the class, and this static non-static member belongs to the object. So if I have a static int, let's call it maybe count. We want to count how many objects are created inside the program, how many parents object or the child object of child object, which is of type parent, is created. This is an ASO relationship. A child class is a parent class. Okay, so right now this static variable belongs to the class, and one copy of this static variable is created per class load. Okay, for this parent class, only one copy of this static a variable is created, and that same copy is shared among how many objects we create. If we have child C1, C2, C3, C4, all these children will have access to the same copy of this static variable. But in case of non-static variables or instance variable, a separate copy of these are created per object. Okay, if I want to quickly visualize that for you because it's important and some people get confused for that, we know that the new keyword is going to create an object. If I say child C1, we have a heap memory area. So the new keyword will create an object here, C1. And when I say child C2, another object will be created in the heap memory. They will have a separate memory address. They will occupy different memory locations. And each object will have a separate copy of its instance variables. We have an instance variable name. C1 will have a name, for example, as X, maybe XYZ. And C2 object will have another copy of the name variable, and it can have or hold different value, for example, A, B, C. But when it comes in static variables, one copy of the static variables are created in memory area. Count, only one copy is created, and this C1 object access the same copy or share the copy, and C2 will access the same copy. If we have C3, C3 will access the same copy, and the same value is shared among all the objects of the class. Okay, that's why static members belong to the class, and only one copy of that is created in the memory, and that copy is shared among all the objects. But in case of non-static members, a separate copy of that non-static member is created, and each object will have its own copy. That's why objects are made unique or distinguishable from the non-static variables, because they take different values. Okay, if I clear that, go here. Now what happens? Beside these static variables or non-static variables, we can have methods. We can have static methods and non-static methods. The same way static methods belongs to the class and non-static methods belong to the object of the class. We can also have blocks. We can, as a member of the class, we can have static blocks and non-static blocks. A static block, and we have non-static blocks. Some people call it class block that belongs to the class itself, or non-static block, or we call it object block. So static blocks belong to the class, but non-static block belongs to the object of the class. So if I can do the same with my child class here. Inside the child class, I can have static blocks and non-static blocks. So to define a static block, I can put a static, then the block, and I want to put lines of code that I want to execute, and whatever logic or initialization or instantiation I have. Is out, maybe parent static block. Okay, inside the parent class, I have some static blocks here. And for the child class, let me copy this, be a little bit lazy, put it here. Maybe I say child static block. So now what happens? What happens now? When I call C2 equal to new child, so I'm making a call to the constructor of the child class, this constructor. In order to make a call to this constructor, I need to load this child class to the memory first. Okay? Because I'm using this child class, I need to load it to the memory first, then I can create an object of that. But before I can load the child class to the memory, I depend, or the child class depends to the parent class. Before anything, I need to load the parent class to the memory and instantiate an object of the parent class, or create an object of the parent class. And based on that, we can create an object of the child class. So right now, when a class is loaded to the memory, the first thing it does, it will set all its static members, create its static members, and if we have initialization, it will get initialized to the values. Then all the static blocks will get executed. Before we do anything, before we create the object, before we call the constructor, uh, at the time of class load, when we load the class to the memory, all static members are taken care. First, we set the static member variables, initialize them, and execute the static blocks. And if we have some initialization purposes or whatever setup, so basically we use the static blocks and non-static blocks for initialization purposes, for project setups or default values we have or want to set. For any piece of code that we want to execute at the time of class load, we can put it inside the static block. But non-static blocks belongs to the object, and if we have some logic or initialization for each object creation, we can put it in a non-static block. Okay, we will learn about this non-static block. So for now, the static blocks get executed once per class load. Once class is loaded, no matter how many objects of the class we create, child class or parent class, this is static blocks get executed once. So we load the parent class first, executed this, then we come back and we load the child class, this get executed. Now we are making a call to the child constructor. We come back here, make a call, the same flow as we saw before. Okay, so this is the flow of execution for a static block. Let me say that again. So when we try to build an object of the child class, we need to load this child class to the memory. But before we load that, we load this to the memory. And the first thing that we do while the class is loaded in the memory, we are setting the static variables here. Then we execute the static blocks of the class. Then we come to the child class, load the child class to the memory, and if we have static members here, we set that, and then we execute all the child class static blocks. So third, this one get executed. Then we come here and we make a call to the child class here. We get a name here, we pass the name to the parent, this one will get called here, and fourth, we print this one, we set the value, execution come here, and fifth, we print this line of code, we exit out of the loop, and we come to the main method. Okay, so let's see and run the code very quickly. I'm gonna run it, then I can show it to you using a debugger, and let's see. So first we have a welcome here to the main method. Then before we call to the constructor of the child class, what happens? We load the parent class, the parent static block gets executed. Then we load the child class, the child static members are taken care. Then once the classes are loaded in the memory, then we can create the objects. First we create the object of the parent class, the constructor of the parent class get executed. Then based on the parent class, we can create the child class because we inherit some properties from the parent object. First we need to create the object of the parent type. Okay, so now what happens if I have two objects of the child class? Now what do you guys think? How many times? But before that, let me quickly show you through debugger also, then we can take a look at that one also. If I put a debugging point here or breakpoint here, let's debug our project, step in. Before I go to the constructor, let's see what happens. Before I call the constructor, the parent class gets loaded first. See, first we set or initialize all the static members. As I said, only one copy of this is created and shared among all the instances of the class. So this gets set and we initialize it to 0. Let's step in. Then we come to the static members of or static blocks of the parent class. So now the parent class is loaded in the memory. We set the static member and executed the static blocks. We come and take care of the child class. Inside the child class, we don't have any static members, so directly at the time of the load of the class, before we do anything with the constructor, we take care of the execution of the static blocks. So if I go here, so this one is got executed. I come back to the static block of the child class, get executed, and I can call the constructor again after that. Let me get out of that. See, the execution come back here. Now the two classes are loaded in the memory. We have them in the memory, and we can create objects of that. First, we create an object and instantiate an object of the parent, and based on the parent, we can create an object of the child class. Let's see. The constructor got called. We call and pass the child value to the parent class. We want to build the parent class, then we can inherit this name from the child class. Okay. See, we came back to the child constructor. We set the value. We don't have anything. The object is not created yet. As soon as we come back here, the object is created. So this is the flow of execution. We can see our static blocks got executed once, and we have the constructors. But what happens if I have two objects or three objects of the child class, or n objects of the parent or child class? So the respective constructor get called, but for static members, they get called once per class load. No matter how many objects we create, only these two lines of code get executed once. See, we have the parent static block first, the child, then the parent constructor, no argument constructor, because first we create a no argument object, then the parent argument constructor. This one. We saw the flow of that. Okay. Now let's see. What happens if I have some non-static blocks also inside classes. I have my parent class here. I want to create a non-static block. I can create a non-static block by just putting curly braces. As I said, this non-static block belongs to the object of the class, and this get executed per object creation. This get executed once per class load. We know that class gets loaded only once in the memory, and this gets executed once per object creation. Okay, so let's say if I want to out parent no parent non static block, and here if I want to create a static block here, I will say out child non static block. Now we have non-static blocks for both the classes, and they get executed per each object instantiation, no matter whatever constructor we call. No matter whatever constructor overload we use to build an object of the class, this blocks get executed per object creation. So here I create a no argument constructor to instantiate an object of child, and here I call an argument constructor. So no matter whatever overload of the constructor we use, this line of code get executed once per object creation. Now what happens? Same flow. Once if I just want to use one object, child C2, the parent class get loaded to the memory. First, we set this line of code and we print. Let me see if I can do that. Maybe here. Where is that? Okay. Now let's see. Now let's see what happens. Okay. We are making a child object. For that, we need to load the child class to the memory. So the child class get loaded to the memory, but before we get load to the child class, we need to load the parent class. So once the parent class is loaded, the first thing it does, it's going to set this one. We saw that. The second thing is going to execute all its static blocks. Now the parent class is loaded in the memory. We come to the child class and we want to load the child class to the memory. If we have a static members, that will be taken care of, but we don't have anything here. We come to the static blocks of the child. So the third, this one, get executed first at the time of the class load, the child class load. Okay. Now we come back here and we call new, the new keyword, and we call the constructor. We are calling the overload constructor here, like child c2 equal to new child, and we pass a name. So we make a call to this constructor. We get a name and we pass the name here. The execution comes here to the parent class. And fourth, before we call or make the object of the class, if we have any non-static blocks before the constructors, the non-static block gets executed. Okay. Before we execute the parent constructor, the execution comes here. We have a non-static block here. So fourth, I believe fourth, this one gets executed before we execute anything inside the constructor of a class. All its non-static blocks get executed. Then once we executed the non-static block, we come to the constructor and we execute this one, fifth. We set the name and the execution come back to the not here, maybe to the constructor of the child class. From here, execution come here, and 6, we print this one. From here, the execution goes back to the main, and the memory address is returned, and we set the memory address to C2 reference variable. Okay, so remember, for non-static members, for each object creation, before we, and also we forgot the non-static block here also. Sorry, let me see here. In the 6th step, once we set the variable in the parent constructor, the flow comes to the child constructor. But before we do anything with the child constructor here, we have a non-static block here. Before the constructor, the non-static block gets executed. So we come and execute at the 6th step this non-static block of the child. Then after this, we go back to the constructor, and 7, we print this one. And after we build the child class, the execution comes to the main. The object is returned, and we store the object or the reference of the variable C2 inside the C2 reference variable. Okay. So remember, before we execute the constructor of the class, all its non-static members get called. But before everything, the static members at the time of the class load. Okay. So now let's see. Excuse me. What I'm gonna do is I'm gonna put a breakpoint here. Let's run our code, debug our code, and see what happens. Step in. Before we call the child, what happens? We load the classes. First, we load the parent class, then the child class, because the child class depends on the parent class. Okay. Let's see what happens when we load the class. We don't load the child class first. We load the parent class. See. Now we are loading the parent class. We are inside the parent class, and we set all the static members. Once we set and initialize the static members, we will look for any static blocks. We have a static block. We go and take care of that. Next execution come here, a static block. Now we don't have anything else. So the parent class is loaded in the memory. Now we are coming back to the child, and we want to load the child class. We take a look if we have here any static members, but we don't have. We directly go to the static block of the child class. See, the execution came here. This line of code get executed, and if we have an initialization or setup logics, that all of them get executed at the time of the class load. Now our both classes are loaded, but we haven't made any call to the constructor. Classes, both child and parent, are ready in the memory. Now we can instantiate some objects from those classes. First, we need to instantiate the parent class, and based on the parent, we need to instantiate the child class. Now we are coming here and we are making a call to the constructor of the child class. We saw the flow. It comes to the super. We pass the value to the constructor of the parent. We call the argument constructor of the parent. But here, before we do anything with the constructor, what is going to happen is going to look for any non-static block. It will come here and execute the non-static block. See, we didn't execute anything inside the constructor. We came directly to the non-static block. Let's run it. Then we come here and execute the parent constructor, set the value child to the child, and we jump back. We are done. We jump back to the constructor of the child class from where we call it from here. So we call this one, we take care of this call, and we come back here. But before we come to the child constructor, we are taking care of all the non-static blocks. So the non-static blocks get executed, then we execute the child constructor, then we come back to the main method, and if we have anything, we print that. Now our child C2 is created, and we can visualize that here. Let's see what we got. We got a name here, and the value is child. And if we have more attributes, we can see that. Okay? For the object. So now you answer this question. What happens now? If I create 2 more or 3 or 4 objects of the child, what happens now? Exam. How many times this one gets executed? Pause the video and see if you can answer this question. What would be the output now? How many times this get executed, how many times this get executed, and how many times this get executed? And what is the flow? Which one first get executed? So we said for each object creation or instantiation, no matter what overload we use the no argument constructor and argument constructor. For each object instantiation, that this get executed once. But this one, for each class load, only once for the parent class and once for the child class. No matter if we have hundreds of the children class or parent class object we create, this get executed once. So let's run it and see. Our classes are loaded. The parent static block and the child static block, they get executed once. Then we have the parent non-static block, the parent no argument constructor, because we are first calling the no argument constructor of the child. We are here, and for this no argument constructor, the parent non-static got executed once. Then we come to the child non-static block, child non-argument constructor. So now C1 is created. Okay, here for C2, we create call the parent non-static block, then the parent constructor, the argument constructor, the parent child non-static block, and the child argument constructor. Okay, but these 2 lines of code get executed once. The class load. We can, since we know this line of code get executed for each object creation, maybe we can increment our count value here in the non-static block and see how many objects are created. I can just say count plus plus. I can print it here in the main menu and see how many objects are created. This out. This out. Parent, since it's an static member, we don't have to create an object of the class. We can access the static member directly using the class name parent.count. So this count is shared between the C1 and C2. Count is 2. If I Control D, now we are calling, creating 3 objects. The count should be 3. I believe we can access them using the object also. Let's see, count instead of the class name. If I say we cannot access that directly using C1 dot count. We can access that, but this is not a good practice. C2 dot count. Let's say C3 dot count. All of them are going to have the same value, because the count value is shared among all the objects, and we get a warning that it's not a good practice to call static members using the object. Either we can create a public method, an instance method to access this one. For example, I say public and I create an instance method get count, and this method belongs to the object of the class. This is a non-static method, and I can just return the count value. I can do that from an instance method or non-static method. I can access everything. I can access the instance variables and static variables, okay, or class variables. But it is not the other case. If we have a static method, we cannot make a call to instance variables, okay. We will see, take a look at that. So this is a good practice to create an instance variable, instance method, and return the static variable values. So right now, instead of accessing the count directly from the object, I can say c1.getCount, c2.getCount, and c3.getCount. So this is a bit better practice. Let's run it. We get the same value because the count value is shared among all the objects of the classes. But if I want to print, for example, child2, if I give a name, if I want to print the name for each child, the name is going to be distinct for each object. If I say south name and I want to say c1 dot name, we don't have any getter and setter. So just for practice purposes, I'm gonna directly access them. C2 dot name. Since this is instance variable, we get a separate copy of that for each object. Each object will have a different version of this name variable. But for this static variable, each object will have the same version, the same copy, okay? If I run that very quick, we can see the first, we don't pass any name, we get a null. For the second, C2, we get a child, and for C3, we get child3. Okay, let's put a child3 and maybe child2. For C1, the default is null. For C2, we get child2 and different version. Okay, I believe we can print, let's see, system dot identity hash of c2 dot name. Let's see the hash value of them, because those are different, what do you call, different objects, okay, different objects. Can I call that here also? Let me see. Okay, C1, C2, C3. I want to show you that we get 3 different version or copy of the name variable, okay, with 3 different hash codes. The first one is null. This one has this hash code ending with 346, and this one has a different hash code. So that means that we get a different version or a different copy of the instance variable. But when it comes to the static variable, we get the same copy. We can print that information here also and see if the hash code of that is the same or not. Okay, as I said, if we have a instance method, if I go to the parent class, I have a static member variable and a non-static member variable. If I have an instance method, this is an instance method which belongs to the object of the class. I can have another instance method, for example, public void print info. From this instance method, I can access everything. The static methods, the non-static method, the static variable, the non-static variable. I can do access everything from the class. Okay, I say assout name plus this dot name, and I just want to print the count also count. I will say, can I say this dot count? No, because count belongs to the class and we cannot use this. This keyword refers to the current object, right? So I can use the get count instance method we created, or I can say only count. See, I could access both the instance variable and a static variable, or the object variable, or the class variable. But in case of a static methods, public, static, void, get, count, number, for example, from a static method, I can only access the static variables, not the non-static variables. Okay. If I say assout name this dot name, I cannot access that. From a static member, I cannot access a non-static member. I say cannot be referenced from a static context. Okay, a non-static context cannot be referenced from the static context, but vice versa is correct. Okay, I can only access count here. Count plus count. Okay, so I believe that's all. And if you have any question, just let me know. We can discuss further. And if you know anything about static members and non-static members, just let us know in the comment section. And thank you for watching. See you in the next video. Bye bye.